Now on to our fourth example of rationalization using conjugates. We're looking at the expression root 2 plus root 3 over root 2 plus root 5. So all we've really done here is complicate the expression a little bit, so we have radicals on top to worry about as well. So this is just going to be a little bit more complicated in terms of simplification, but the process remains the same. All right, so let's simplify it. We have root 2 plus root 3 over root 2 plus root 5. And the idea is to multiply by the conjugate of the denominator. Yes, I'm aware that we have radicals being added on top, but we don't really care too much about that. The goal is to get rid of the radicals in the denominator. Okay, how do we do it? Multiply by the conjugate of the denominator. That is, multiply by the negation of the center term here. So we have root 2 minus root 5 over root 2 minus root 5. Okay? So that's the conjugate of this bottom thing here. So I'm going to put everything in parentheses because everything is going to need FOILed. Okay, so now the numerator is going to require foiling, and that's going to be kind of complicated. We'll worry about the denominator after we deal with the numerator. So for now, we have root 2 times root 2 plus root 2 times root 5. So do that, we have root 2 times root 2, minus actually, because we have a minus sign there. So we have minus root 2 times root 5. And then we do the same thing with this root 3. So first and then second. So we have plus root 3 root 2 minus, oh gosh, I'm going to run out of room. Root 3, okay, let's move that slightly to the next line. Minus root 3 root 5. Problem with using a tiny little whiteboard. Okay, so that's the entire numerator. We'll simplify that in the next step. Thank goodness. And the denominator here, we have a difference of squares instance. So we have root 2, root 5, plus, minus. So this is going to turn out to be this times this, minus this times this. Okay, so that gives us square root of 2, quantity squared, minus square root of 5, quantity squared. Okay, so simplifying, I'm going to pull my equal sign all the way over here because I don't like running out of room. I have root 2 times root 2. Combining these all under one radical, I have 2 squared square rooted. So that gives me just 2. Minus, well, I can put these under the same radical because the radical power is the same. So I have root 2 times 5 plus, do the same thing with the second term here, or the third term. So put those all under the same radical. So we have 3 times 2. And then the last one, minus radical 3 times 5. Okay? And now in the denominator, we can cancel the radical with the power. So we have 2 minus, well, we can cancel the radical with the power here too. So we have 2 minus 5. Okay? Notice that in the numerator here, in the next step, we don't have the same thing in any of these guys. Like, sure, yes, we have a 2 and 2 and a 3 and 3, but we don't have this, like, we don't have a 2 and 5 and a 2 and 5 and a 2 and 5. So we can't combine these guys. We're stuck with what we got. So I would just multiply these guys out so you have a number inside the radical. So you have 2 minus root 10 plus root 6 minus root 15. All over, well, 2 minus 5 is minus 3. Okay? So none of this top stuff simplifies. It just stays ugly, unfortunately. But sometimes that's how things roll. But I do have a minus sign here in the denominator. I can't cancel this 3 with anything, so it's stuck here in the denominator. But this minus sign I can pull up top, because division by -1 and multiplication by -1 are going to give me the same thing. So this is the same as minus 2 minus root 10 plus root 6 minus root 15 all over 3. Same thing. Okay? And if you like, you can distribute this minus sign through and change the signs of everything. So you could stop here, that's fine. Or if you wanted to do the additional step, minus 2 plus root 10 minus root 6. All I'm doing is changing signs because I'm multiplying this minus throughout everything, leaving me with this whole thing, and all over 3. So this is also done and completely simplified, because we can't break down these radicals anymore, we're stuck. So at this point, we are done with this example, and can move on to example 5.